Welcome to Ask and Learn.
Here we'd like to use the first 10 terms. So that'll be the 10th partial sum as 10 to approximate this infinite sum here from 1 to infinity. So now S10, the first sum of the first 10 terms here. So we won't write all of these out, but let's just, before we would insert this in a calculator, this is what we would end up entering here, all the way up to n equals 10. And this would take too long here to write this out by hand. So going to a calculator, I approximate this. And that will be one of our answers, the approximation of the infinite sum. The question would be, and that's where the error will come in, is how close is this approximation to the actual infinite sum? Because 10 terms isn't that many, so it might lead you to think that the approximation is not a good one. So a question mark there, and that's where the error will come in. So let's note the following, that if we define Rn to be the consecutive ratio of an plus 1 over an, where this is my an here, and then divide by an, and if you take a limit of that as n goes to infinity, this will just become a 1 and then 1/2. Cancel those 2 to the n, you just have 1 over 2. Also, Rn is decreasing sequence. One way to show this, so if you look at Rn, we could simplify our previous Rn up here before I canceled out. That could have been written as n plus 1 over 2n. Now, to show it decreases, you have to either show this, or if you define f of x to be x plus 1 over 2n, this is usually preferred and works better in many cases. The second one here, show f prime of x is negative if x is bigger than 1. These are both true here, and so I would recommend just writing this one out and using the quotient rule. So now, the reason I'm checking these conditions here is because we want to use exercise number 46, and I'll go to the next page and write this out. So number 46, we check the hypotheses that are needed on Rn. So now we can say the following, that the remainder after adding 10 terms, capital Rn, is less than or equal to this term here. So this is all due to this previous problem here. So now, just using n equals 10 and plug it in, and we see what we get. That gives us R10, and then here we'll have A11, R11. So remember, definition of Rn is an plus 1 over an. So here we have R11, so that'll be A12 over A11. And this could be simplified as a fraction, or you could just go to the calculator with this as well. And that's the error that we get. So in the previous page, we gave the approximate value. I'll recite that here. And the error was only this large, and that resolves the problem.